What is NAT? NAT stands for Network Address Translation. And what this does, it is a service used in your routers that translates one IP address or a set of IP addresses to another set of IP addresses. This helps IP preservation. Reason being, you can limit the number of IP addresses that interact or communicate over the internet. And this was implemented because of the limited number of IP addresses they have for the IPv4 scheme. The NAT works in such a way that you can translate a private IP address to a public IP address, and vice versa. You can translate a public IP address to a private IP address. So this helps preserve the limited number of IPv4 public addresses that they have. And even though they have over 4 billion IP addresses, or even though they had those originally, they didn't foresee the shortage of public IP addresses. So that led to the development of a next generation IP address, which is the IPv6. So the IPv6 is a permanent solution to help resolve the issue of limited IPv4 addresses. As we noted, we have two types of IPv4 addresses, the private, which is used internally, and the public, which is used over the internet. So in this picture here, we have the picture at the bottom right. We have the internet, we have a router, and we have three different devices. We have three different devices. So the way NAT operates is these three devices are assigned private IP addresses, while this router is assigned a public IP address. So this router is able to reach the internet, and devices on the internet are able to reach this router, but they cannot reach these three devices. So that scheme helps protect this network here. Now, let's say the first device wants to reach the internet. What happens is, once this device tries to reach the internet, this IP address, the 10.0.0.3, is converted by the router to the 67.123.46.76. And this is the IP address that is sent out to the internet or sent out to the public. This is the IP address that is sent out to the internet or to the public. And once a response is sent, it is sent to this router, and this router now sends it to the corresponding device that sent out the request. So that is how the NAT operates. So with this NAT or network address translation, it helps reduce how expensive it would be, given that you had to assign each device a public IP address. And it helps the unnecessary use of public IPv4 addresses, thereby limiting the waste of IP addresses. Okay. So given the limited supply of IPv4, as I had mentioned, the NAT was introduced, and then for a permanent solution, the IPv6 addressing scheme was developed to help tackle or solve the shortage for the IPv4 addresses. Now, with the IPv6, as I mentioned, every device will have its own public IP address. So you'll be able to reach a device using its individual IPv6 address. If you look now, currently, things like your phone already have the IPv address or IPv6 addressing scheme in them. So if you go look at the properties in your phone or about your phone, you see it has an IPv6 address on your phones. So that is already being implemented, the IPv6 scheme. And with the IPv6, we'll have more than 340 undecillion IP addresses. So that is 340 with 36 digits after that. So that is how many IPv6 addresses will be available for devices to use over the internet. Now with the NAT, we have three different types of network address translating schemes. We have the static, the dynamic, and the NAT overload. Those are the three common ones. The static is the case where you have a one-to-one. So this is usually manually done. So you have one device or one IP address corresponds with another IP address, a one-to-one mapping, and that is consistent. Now with the dynamic network address translation, just like you have here in this diagram, let's say you have 3 devices and you have 2 routers. So these 2 routers have the public IP addresses to reach the internet. These devices have private IP addresses. So whenever a device with a private IP address sends a request, the IP address being sent to the internet is based off of the availability of the public IP. So let's say device B sends a request to reach the internet. At a certain point in time, the request might go through the first router here, the 6.123.45.67. And the next time, let's say router B sends the request and this router is currently busy, then that route will go through, or that request will go through the other IP, or through the other public IP, the 67.123.46.76. So this is done based off the availability of the public IP address. So this changes over time and it's not consistent. Now for the NAT overload, this is a many-to-one mapping. So just like we had in this previous slide right here. So we have many devices with private IP addresses mapping onto a single public address. So that is considered map overload. So this router here has different ports. These ports could be assigned different numbers or port numbers corresponding to these devices. So whenever it sends it, this is the public IP address that goes to the internet, and the internet responds to this public IP address, and the request is sent to the corresponding device. So that is called NAT overload or port address translation.